Understanding panel boards that are not 100% rated is crucial for electrical calculations. A panel board not 100% rated signifies its inability to handle the combined full load current of all connected circuits simultaneously at the maximum potential. Several factors contribute to this limitation, including the physical size of the panel board, the quantity and capacity of circuits it serves, and the ratings of the installed circuit breakers or fuses. When performing load calculations for such panel boards, it's essential to consider the derating factor. This factor is typically set at 80%, meaning the panel board is designed to safely carry only 80% of its rated load current. As an example, consider a panel board with a 100 amps rating and an 80% derating factor. The maximum load current this panel board can handle is 80 amps, calculated by multiplying the rating by the derating factor. The calculation of load current for non-100% rated panel boards varies slightly from that of 100% rated panel boards. To accurately determine the load current for a non-100% rated panel board, the following formula is used: load current equals the total amperage of all circuits connected to the panel board multiplied by the derating factor. Let's illustrate this with an example. Imagine a panel board not 100% rated with an 80% derating factor, supplying circuits with a combined total of 100 amps. The load current calculation would be load current equals 100 amps multiplied by 0.8, which equals 80 amps. Understanding the NEC, or National Electrical Code, articles related to panel board ratings and overcurrent protection is important. For example, NEC Section 220.87 regarding feeder or service capacity permits reducing the maximum demand allowed if the authority having jurisdiction deems that in view of the manner of uses and other conditions under which the installation will operate, that it is unlikely that the maximum demand will ever occur. Also, NEC Article 408 covers switchboards, switchgear and panel boards. Section 408.36 requires that panel boards shall have a rating not less than the minimum feeder capacity required for the load computed in accordance with Article 220. Section 408.38 requires overcurrent protection of panel boards. Also, remember to consider ambient temperature and conductor insulation types when calculating ampacity per NEC Table 310.15. When dealing with continuous loads, which are loads expected to operate for 3 IOs or more, NEC Section 210.20 requires that the overcurrent device be rated for not less than 125% of the continuous load. This is equivalent to derating the circuit to 80% of the overcurrent device rating. If a panel board supplies both continuous and non-continuous loads, the calculation must account for both. Firstly, determine the total continuous load. Secondly, determine the total non-continuous load. Thirdly, multiply the total continuous load by 1.25. Fourthly, add the result to the total non-continuous load. This gives the total load in the panel board. The panel board must be rated to handle this total load. To choose the correct size of the conductors feeding the panel board, use NEC Table 310.16, accounting for conductor insulation type and ambient temperature. Remember to apply any applicable adjustment or correction factors as per NEC 310.15. For example, if multiple current-carrying conductors are bundled together, an adjustment factor must be applied. Also, ensure that the panel board is properly grounded and bonded according to NEC Articles 250. Consider voltage drop in the circuit conductors. A voltage drop of more than 3% for feeders and 5% overall for feeders and branch circuits can cause equipment to malfunction. Use the voltage drop formulas in NEC Chapter 9 to calculate the expected voltage drop and increase conductor size if necessary. Before performing any electrical work, de-energize the circuit and verify with the meter. Always follow safe work practices, including wearing appropriate personal protective equipment, or PPE. If the panel board supplies motors, follow the requirements in NEC Article 430 for motor circuit conductors, overcurrent protection, and control circuits. Motor loads often require larger conductors and overcurrent devices than non-motor loads due to the inrush current when the motor starts. Also, consider any future expansion plans when sizing a panel board. It is often wise to choose a panel board with spare capacity to accommodate future loads. Label all circuits clearly and accurately. This helps with troubleshooting and maintenance in the future. Use a panel directory to document each circuit's purpose and the areas it serves. Keep the panel directory up to date as circuits are added or changed. Periodically inspect panel boards for signs of damage, overheating, or loose connections. Address any issues promptly to prevent electrical hazards. Infrared scanning can be a useful tool for detecting hot spots in panel boards, indicating potential problems. Ensure that all panel board covers are in place and securely fastened. This protects against accidental contact with live parts. Keep the area around panel boards clear of obstructions to allow for easy access and ventilation. Panel boards should be readily accessible for maintenance and inspection. Follow all applicable federal, state, and local electrical codes and regulations. Consult with a qualified electrical engineer or inspector if you have any questions or concerns about panel board installations or calculations. In summary, calculating the load current for non-100% rated panel boards requires careful consideration of derating factors, continuous loads, and applicable NEC requirements. Accurate calculations and proper installation practices are essential for ensuring electrical safety and reliability.